The Arctic, a vast expanse of white and blue, holds countless mysteries. Among them, the polar bear stands as a master of survival, navigating an environment that demands exceptional abilities. Imagine a world where food is scarce, hidden beneath thick layers of ice. How does a predator find its prey, a vital meal like a ringed seal, in such a desolate and seemingly scentless realm? The answer lies in an extraordinary sensory gift, one that defies human comprehension, allowing these magnificent creatures to detect a seal from nearly a mile away, even when the ice forms a formidable barrier between hunter and hunted. Life in the high Arctic is a perpetual challenge. For the polar bear, the vast frozen ocean is both its hunting ground and its home. Seals, rich in blubber and essential for survival, are the primary food source. Yet, these seals spend much of their lives beneath the ice, emerging only briefly to breathe or rest. The visual cues are almost non-existent. Without a method to locate these elusive prey animals, a polar bear would face an impossible task, constantly expending energy in a fruitless search across endless ice sheets. This underscores the sheer necessity of their unique sensory capacity. In an environment where sight is often obscured by snow, fog, or vast distances, and sound is muffled by ice, the sense of smell emerges as the ultimate tool for discovery. It's not merely an enhancement, it's a fundamental pillar of the polar bear's existence. This remarkable olfactory prowess isn't a mere detection of faint odors, it's a sophisticated system that translates nearly imperceptible chemical traces into a precise map of potential prey. Every breath a seal takes, every movement it makes, releases a molecular signature into the frigid air, a signature that the polar bear is uniquely equipped to intercept. At the heart of this incredible ability lies the polar bear's nose. Far more than just a respiratory organ, it is a finely tuned instrument, a biological masterpiece designed for unparalleled detection. Its structure is vastly different from that of most mammals, engineered to capture and process the most delicate scent molecules across immense distances. The cold, dry air of the Arctic is perpetually drawn into this specialized sensory chamber, carrying with it the invisible whispers of the environment. Every sniff is a calculated action, a deliberate intake of information from the surrounding world. For scent to travel, there must be a medium, and in the Arctic, that medium is the air itself. Wind, often a relentless force in polar regions, plays a crucial role. It carries scent molecules across the expansive ice, sometimes for miles, acting as an invisible conveyor belt for information. The polar bear, with an innate understanding of these atmospheric currents, often hunts by strategically moving upwind, allowing the wind to bring the telltale signs of prey directly to its highly sensitive nostrils. It's a dance with the elements, a natural harnessing of meteorological forces. What exactly is the polar bear detecting? It's not the seal itself, but rather a cascade of volatile organic compounds, tiny molecules released from the seal's body, its breath, and its waste. These microscopic particles drift through the air, carrying the distinct chemical signature of the animal. Even in incredibly low concentrations, these specific molecules are recognized by the bear's olfactory system. It's a testament to the sophistication of this sensory apparatus, capable of distinguishing specific prey odors amidst the vast complexity of other environmental smells. Ringed seals, the primary prey, spend their lives interacting with the ice from below. They create and maintain breathing holes, called egglets, keeping them open even when the ice can be several feet thick. These egglets are vital arteries, connecting their sub-ice world to the air above. Mother seals also build snow layers over these breathing holes to protect their pups. It is from these points, these crucial connections to the surface, that the seal's distinctive odor begins its journey, a journey that the polar bear will intercept. While ice appears to be an impenetrable barrier, its solidity is not absolute. It can be porous, fractured, or thin in certain areas. Scent molecules, though tiny, are persistent. They can escape through microfissures, cracks, and the very breathing holes seals create. The frigid temperatures also play a role, preserving these scent molecules rather than quickly dissipating them, allowing them to linger and accumulate. Thus, the ice, while formidable, becomes merely a filter, rather than a complete blockade, for the invisible signals of a hidden seal. Specific atmospheric conditions further aid this detection. Warmer air rising from the seal's breath or body beneath the ice can carry scent molecules upwards through the breathing holes or even tiny cracks in the ice. This creates a subtle plume of odor, an invisible signal tower for the polar bear. The bear's ability to pick up these incredibly faint, upward drifting chemical traces from a distance is nothing short of astounding, transforming the harsh Arctic air into a detailed scent map, guiding the hunter toward its unseen prey. Inside the polar bear's impressive snout lies a complex world of sensory tissue. Its nasal passages are exceptionally intricate, lined with an expansive surface area of specialized olfactory receptors. These receptors are the tiny antennae that bind with specific scent molecules, initiating a signal. The sheer number and variety of these receptors allow for the detection of an incredible array of odors, even those present in minute quantities. This vast internal architecture provides the capacity for unparalleled sensitivity and discrimination. Once the scent molecules bind to the receptors, an electrical signal is sent directly to the polar bear's brain. Specifically, the olfactory bulb, the part of the brain dedicated to processing smells, is exceptionally large and highly developed in polar bears. Here, these raw electrical signals are translated into meaningful information. The brain doesn't just register a smell, it interprets it. It identifies the specific type of animal, its proximity, and even its condition, allowing the bear to make crucial decisions about its hunting strategy. The Arctic environment is not without its own scents: snow, ice, salt water, and other animals. The polar bear's olfactory system must possess an incredible ability to filter out this background noise and focus precisely on the faint, specific scent of a seal. This discrimination is key. It's not enough to simply detect a smell, the bear must correctly identify the smell that promises sustenance. This refined filtering capability prevents energy-wasting pursuits of irrelevant odors, ensuring efficiency in a demanding landscape. Just as humans use two ears to determine the direction of sound, polar bears employ both nostrils to pinpoint the source of a smell. By comparing the strength and timing of the scent molecules entering each nostril, their brain can triangulate the exact direction from which the odor originates. This binaural olfaction allows for precise tracking, turning a vague scent into a clear, directional signal. It enables the bear to follow an invisible trail, often over great distances, leading it unerringly towards its concealed prey beneath the ice. The fact that a polar bear can detect a seal from nearly a mile away, through solid ice, is a profound testament to this sensory marvel. A mile in the vast, featureless Arctic feels immense, a distance where visual cues are often obscured. It means that while the bear might be walking casually across an ice floe, its nose is already scanning, processing, and mapping scents from areas far beyond its immediate sight. This incredible range allows for highly efficient hunting, minimizing wasted energy in an ecosystem where every calorie counts. Once the polar bear's powerful sense of smell has successfully located a seal's breathing hole, the next phase of the hunt begins: patience. The bear will often position itself strategically downwind, sometimes for hours, waiting silently for the seal to surface for air. This final stage is a combination of instinct and finely honed sensory input, confirming the presence of the prey. The extraordinary ability to locate the igloo from afar grants the bear the crucial advantage of surprise, a silent sentinel poised for its opportunity. For the polar bear, its nose paints a rich, detailed picture of an unseen world beneath the ice and across the vast distances. It can differentiate between a fresh seal scent and an old one, a live seal and a deceased one, even perhaps the presence of pups. This complex sensory input creates a mental landscape far more intricate than what its eyes can perceive, transforming this seemingly barren Arctic into a vibrant tapestry of chemical information, a constant flow of data vital for finding food and navigating its challenging home. While finding seals is a paramount function, the polar bear's sense of smell serves broader purposes. It is crucial for locating mates during the breeding season, allowing individuals to find each other across immense territories. It helps mothers keep track of their cubs and alerts bears to the presence of other polar bears, which can be rivals or potential dangers. This multifaceted olfactory skill extends beyond mere predation, underpinning nearly every aspect of their social interaction and survival in their isolated world. The polar bear stands as an apex predator, uniquely equipped to thrive in the harshest environment on Earth. Its dense fur, thick blubber, and powerful paws are all vital, but its sense of smell is arguably its most extraordinary asset. It is a testament to the remarkable capabilities present in the natural world, a specialization that allows this magnificent creature to not just endure, but to dominate its frozen realm. This olfactory superpower exemplifies the intricate balance between creature and environment. The polar bear's precise hunting abilities, primarily driven by its acute sense of smell, are integral to the health of the Arctic ecosystem. As a top predator, it plays a vital role in regulating seal populations, which in turn impacts the broader marine food web. The successful detection of seals ensures the polar bear's own survival, thereby maintaining its position as a crucial component of this delicate ecological system. It's a profound connection, where one animal's specialized sensory gift underpins the equilibrium of an entire icy world. From the invisible drift of scent molecules to the incredible processing power of its brain, the polar bear's ability to smell a seal through ice from nearly a mile away is a true marvel. It is a phenomenon that speaks to the profound and diverse abilities found in the natural world, abilities that allow each creature to navigate and thrive in its unique habitat. As we contemplate this incredible feat, we gain a deeper appreciation for the intricate wonders of the Arctic and the unparalleled sensory world of its iconic white bear.